DreamStream, immersive and interactive viewing in virtual reality. Today, users of virtual reality have a great experience. They feel entirely immersed in the digital environment that they see. They can look around it, move around, and interact with it as if they were actually there in that space. In contrast, spectators only see a 2D video feed. These videos are shaky and uncomfortable to watch. Spectators do not perceive the stereo 3D nature of the scene, often lose spatial awareness of elements surrounding the VR player, and lack any form of interactivity or exploration of the scene. To solve these, we present DreamStream. It performs live streaming and 3D reconstruction of an existing VR application. Spectators can then view the reconstructed scene in 3D through a VR headset. DreamStream's 3D reconstruction consists of three components. First is the 3D reconstruction of the scene as seen from the VR player's first-person view. This component is updated at a high frame rate. Next is the 3D reconstruction of the ambient parts of the VR scene as seen from a third-person perspective that is controlled by the spectator. This component is rendered with dimmer intensity and updated at a lower frame rate. It is intended to provide additional context for the VR player's actions. And finally, we have the live 3D reconstruction of the real body of the VR player itself that is captured by a Kinect. This is updated at a higher frame rate. Let's now see a few examples of DreamStream. Here, a spectator uses DreamStream to view a live stream of Skyrim VR. They are using a VR headset too and are also immersed in the scene just like the player. They move around the scene using their own VR controllers. They have access to laser pointers that they use to guide the VR player on where to go in the game. The VR spectator can also choose to see the ambient parts of the scene outside of what the VR player sees. To distinguish this, these ambient parts are rendered with dimmer intensity. While these are updated at a lower frame rate and may have distant objects culled, this provides added context to the VR scene surrounding the player. It also increases the effective field of view of the spectator. For the VR player, besides the VR application that they are using, they would see the spectators as if they were there in the VR scene itself. The spectators cohabit the virtual space of the game as an avatar, and together with their ability to point, makes them feel that they are in the game together. In addition to a VR headset-based interface, DreamStream also provides a desktop interface for spectating. This is called an interactive 2D viewer. This viewer allows spectators to perform similar interactions on a 2D screen. Spectators can choose between 4 different viewing modes. In free camera mode, they can pan, rotate, and explore the VR scene independently. Orbit view allows the spectator to orbit around the player, but always looking towards them. It allows them to obtain different perspectives focused at the player's activity. Follow view places the spectator at an over-the-shoulder view of the player. The view always follows the yaw of the player while the pitch is controlled by the spectator. Finally, it has the standard first-person view. Since such first-person view feeds can be shaky, the spectator can turn on the stabilization. This smooths the camera movement. Without the ambient parts of the scene turned on, stabilization results in black bars at the edges. Turning on the ambient fills these parts of the scene. This results in a more compelling experience for the spectator. In the 2D viewer, spectators can also use laser pointers at scene elements by right-clicking on them. DreamStream works with existing VR applications. Some of these are used in a different way compared to others. In Beat Saber, for example, the low FPS ambient does not make sense, but it is extremely valuable to have the 3D capture of the player playing the game. In collaboration tasks involving design apps such as tilt brush and blocks, the 3D capture of the user might not be as important and may even occlude the primary task. Here, a spectator is guiding a VR user on a stroke to be drawn in the VR painting in tilt. Other applications in which we tested DreamStream include blocks, Walls of Wizard, Trainer VR, and Fallout 4. To work over existing applications, DreamStream intercepts VR platforms' rendering pipeline. It extracts video and depth buffer. It then composites them to get two separate streams that are optimized for scalable video transmission. The primary stream contains high frame rate data about the VR player's first-person view. A secondary stream contains high frame rate data of the VR player's Kinect information and low frame rate data of the ambient parts of the VR scene. More details are discussed in the paper. We conducted user evaluations and compared DreamStream with Transceiver, a prior system targeted at asymmetric VR collaboration. With DreamStream, users found it easier to communicate to the VR player and understand the VR scene. They also found it more enjoyable, immersive, and felt that it made them more co-present with the VR player. These are detailed in the paper. Thank you for listening.